So, welcome to this session of the Fluid Dynamics question and answers. So, in this session, we're trying to solve these questions here. So, the question says the fluid velocity u is defined in terms of the spatial coordinates by. So, as you can see there, if you can't see clearly, don't worry. I'll write the question after reading the question to you. So, it says we are supposed to find the representative of the curl of the fluid velocity. So, the curl is represented by this, as you can see here. You are supposed to evaluate the curl of u. After that, you are supposed to also evaluate the curl of u at the point p equals root of 302, and you're supposed to find the values for u. So you're supposed to find for u1, u2, and u3. And based on our response above, you are supposed to tell whether our vector field is one of these: rotational, uniform flow, none of the options, irrotational. Okay, so let's go through that. So the u, or the vector field, which was given in the question, is what you can see here. Alright. So note that the formula for computing the curl of a vector field is what you can see here. So the determinant ijk del del x del del y del del z. We have s squared y, 3x minus z cubed, and 4y squared. Alright. So we are going to find the determinant of this 3 by 3 matrix. So in finding for the determinant, we'll first have to bring our I here, then we ignore this portion, so it will be this times this, then minus this times this. So that's what we see here. When we go to our j component, minus j component to be this times this, then minus this times this. That's what we can also see here. Then when it comes to the k component, it is going to be this times this, then minus this times this. So that's what you can also see here. So now you're supposed to do a partial derivative. So the partial derivative of 4y squared with respect to y is simply 8y. That of 3x minus z cubed with respect to z is minus 3z squared. And here 4y squared with respect to x is 0. X squared with respect to z is 0 because there is no z component here. So that means the whole of this is 0. Then here with respect to x is 3, and here is x squared. So that means you're going to get 8y minus 3z squared I minus j times 0, then plus k times 3 minus s squared. So simplifying further, we are going to have 8y plus 3z squared I, then all plus 3 minus s squared k, right? So this is going to be the curl of our vector field u. So you can find that here. So where is it? So that means this happens to be our answer to the question. So the next one is we are supposed to evaluate the curl at this point. So at the point p equals root 302. So remember it has this component. So this was our curl. So putting in those values inside. So then wherever you find x, we put root 3. Wherever you find y, we put 0. Wherever you find z, we put 2. So this will give us 8 times 0 plus 3 times 2 squared I plus 0j, then plus 3 minus root 3 all squared k. This is because x is root 3, then y is 0, then z is 2. So after making a substitution, you realize that this will be 8 times 0 plus 12. So we have 12i here. Then this is going to give us, then this is going to give us 0. So we have 0j here. And this will also give us 0 because 3 minus root 3 squared is 3, which will also give us 0. So that means that component u1 will be 12, u2 will be 0, u3 will also be 0, right? So those are the components. Then it says, is it rotational or irrotational? Sorry, so our vector field is rotational, right? So know that we only say it is irrotational when the curl of f is equal to 0. So that means if you had also gotten u1 to be 0, that's each component being 0, then it would have been irrotational. But since here it is not 0, we have a component here. The I component is 12. Then we say it is rotational. So